Hi students, welcome to today's video. In this video, we are going to study about pressure and thrust. Have you heard about thrust? Maybe a new term for you. Have you heard about force? Yes. Already you have studied in lesson number 9. So when you come to the point thrust, see here when I am applying a force on my palm, I can apply force like this, this way, or I can apply force like this. When I am applying force like this is the direction of the force and this is the surface. So when a force is applied perpendicularly to the surface, that perpendicular force is called thrust. Now, so what is thrust? Force, it can be in any direction, but thrust means the perpendicular force acting on a surface. That is called thrust. Now, coming to pressure. What do you understand by pressure? Pressure means force acting per unit area or thrust per unit area. That is called pressure. Now, if all of you take your pen in your hand and that pointed part of your pen you poke here on your hand. Okay? Now you press. Can you experience some pressure? Yes, its effect. Clear? Now you change your pen like this. The broad part of your pen you press here. Again the same process you do, you press it. Can you experience something? Yes. So whether the first case or the second case, you understand more pressure is exerted. The same pen we use on your palm and you only pressed the same way both the cases, but first case when it is like this, it is pointed. As a result, the area is very less. You felt more pain when you pressed here because the pressure is more inside. And second case, the area is more. As a result, when you pressed like this, the pressure is less. So, when we come to this, a force applied on blunt pin, it does not go more inside the wood. So here this is the blunt pin, a wood piece is there. If you press it, it will not go much. But it is a pointed pin. When it is pressed too much, it is going inside. That means it depends upon, even if the same force is applied, but the area is less, pressure will be more. Now we can take, see here there is a brick. When you are having a thing like this, cuboidal shape, see here it is a face, here it is a face, here it is a face. When this part comes in contact, what happened? This full part, that is the area is more, therefore the pressure will be less. But on the contrary, you press like this, here the area is less, therefore the pressure will be more. So, pressure is equal to force upon area, that is P is equal to F upon A. It depends upon applied force and on the area of the surface. Now coming to the pressure. Coming to pressure, let us see, as the area increases, pressure decreases. Area decreases, pressure increases. Based upon this, in our everyday life, we can find out many examples. First is, see, school bags are wide strap. When you go to the market to buy school bags, will you select a school bag with very thin, narrow strap or a broad strap? You will select the one with the broad strap, because if it is broad, the area is increasing, pressure will be less. Otherwise what happened? Narrow strap, so area is less, more pressure will be there and you will get pain. Then it comes to a knife. So knife, what is it is used for? Cutting. So the side, this end will be very sharp, area should be less, very sharp, then it will easily we can cut. Now tip of needle should be very sharp. Pressure of the ground is more when a man is walking than he is standing. Now, because standing, more area comes in contact. Depression is much more when a man stands on the cushion than when he lies. When he lies, more surface area. Stands on cushion, less surface area. So, less surface area, more pressure. The tractors have broad tires. All the heavy vehicles, you know that they are having broad vehicles, broad tires. The reason is that otherwise it will sink into the mud. So, more the area, less the pressure. Then, it is easier to walk on soft sand if we have flat shoes, while rather than shoes with sharp heels. Sharp heel, more pressure will be there, it will sink. Foundations of buildings and dams are laid broad at the bottom to decrease the pressure. So, bottom level for dam, foundations, etc., it should be broad. So, the pressure will be less, otherwise the pressure will increase. Now, we come to the next point, that is fluid in pressure in fluid or fluid pressure. Fluid pressure very easy to understand. When we are considering fluid pressure, you take a milk pouch, then you make a small hole at any one part of that pouch and you just apply, you press or you apply a force on its opposite side. Immediately what you see, through that small hole the milk comes out. So from your experience you can understand that wherever that hole is there and whichever part you press, its effect you are able to experience. That means that pressure is equally exerted to the fluids. Is it clear? When pressure is applied to any part of the fluid, that is equally distributed to all parts of the fluid. This is called Pascal's law. Then coming to a fluid, what do you understand by fluid? Anything which flows, that it can be a liquid or a gas. So, always understand that in a fluid, the pressure exerted at any point, it is equally distributed to all parts of the fluid. And coming to pressure, you know that it is in 360 degrees, any direction it will be applied when it comes to a fluid. Therefore, mostly we say that pressure is a scalar quantity. And what is its unit? Newton per meter square or Pascal. Now, we come to the next thing, buoyancy. This every one of you have experience. If you take a mug and you fill it with water and that filled the mug, when you insert inside a big bucket filled with water, when it is at the bottom of this mug, this bucket, when you try to lift this mug, you never experience any force. But as soon as the mug comes on the surface of the water on the bucket, you feel its weight. Yes? This is because when the mug is inside the water exerts an upward force on the mug. As a result, it comes up. You know that when you take a leaf or you take a stone and you try to keep both on the surface of a bucket filled with water, you can immediately see that the stone is immediately going down while the leaf is floating, because when it is inside the water is exerting an upward force on the object which is fully or partially immersed in that water. So, due to this upward force, if this upward force is more, the object is coming on top. If the upward force is less and the weight is more, it is going down. So, what is this buoyancy and buoyant force? Buoyant force means when an object is fully or partially immersed inside a liquid, the liquid exerts an upward force. This upward force is called buoyant force. See? Buoyant force and the tendency of exerting buoyant force on an object by the fluid, which is called buoyancy. So, buoyancy will be always, the buoyant force will be in which direction? Upward direction. See here, you see inside a bucket, see a downward thing, that is the weight, upward thing, that is the buoyant force. Now, if we consider this is an object we are taking, its mass we are measuring, weight of the body in air 60 gram weight by using a spring balance. Now, next we are going to immerse that in a bucket containing water. Now, it is partially immersed. When it is partially immersed, you see the reading on the balance will be 50 gram weight. And the next case, see it is fully immersed. When it is fully immersed, what happened? 40 gram weight. That is a loss of weight happens when it is immersed in it. So, this is about buoyant force. So, we have seen what is pressure, thrust, then pressure exerted by fluids and buoyancy, buoyant force. The remaining part of this lesson we will see in next video. Thank you.